According to the NFPA, the National Fire Protection Association, in 2012, U.S. fire departments responded to 1,375,000 fires. These fires caused 2,855 civilian deaths, 16,500 injuries, and over $12.4 billion in property damage. Death certificates show a 2-to-1 ratio of smoke inhalation versus burn deaths. And for home fire deaths, it's an 8-to-1 ratio. That basically means people die more from toxic smoke than they do from actual burns in a fire. My name is Somie Mossell. I'm Vice President of the Electronic Cable Group. And in my 14 years in wire and cable in this industry, I've been deeply involved in researching compounds, reading and interpreting standards, such as the National Electric Code, which is actually written by the NFPA, the world's leading advocate of fire prevention and public safety. Today I'd like to speak to you a little bit about a compound that is currently in use all over the world, where critical applications where human and equipment safety are essential. The wire and cable industry predominantly uses halogenated compounds, although their use has decreased slightly in the last few years. Typical plastic compounds such as PVC are being phased out in certain applications and being replaced by this new compound. This compound is flame retardant, it emits less smoke, and contains 0 halogens. It's commonly referred to as LSZH, or low smoke, zero halogen. Today we'll review what halogens actually are, what low smoke, zero halogen means, and I will present the pros and cons of the compound. But let's start with a little history lesson first. Several notable fires have increased awareness of the role that wire and cables plays in an actual fire. King's Cross Landing, November 18, 1987. It's an underground railroad system in London. A fire started in an old escalator shaft at the other end of the rail station that was built in the 1940s. 31 people died, 60 people were injured, and the majority of the deaths occurred as a result of smoke inhalation rather than the fire itself. In Dusseldorf, Germany, at the International Airport, April 11, 1996, a fire broke out in the passenger terminal. 17 people died. It took over 1,000 firefighters to extinguish this blaze. All of the victims died from smoke inhalation rather than the fire itself. And it took so many firefighters because of how thick the smoke was in the terminal itself. Damages at the Dusseldorf airport totaled over $1 billion. These catastrophic events contributed to a greater adoption of LSZH as a jacketing compound. So what is low smoke, zero halogen cable? Well, first we must define what halogens are and how they will react in a fire. A little chemistry lesson for you now. Anyone remember what this is? This is the periodic table. Here are your halogens, right here. They're elements such as fluorine, chlorine, and bromine. And under normal conditions, halogens are very stable. We use halogens every day. It's in anything that has PVC in it has halogens. Lunchboxes, toys, pens, wire and cable. Under stress conditions, however, such as a fire, halogens emit a very poisonous gas. They become highly reactive. Specifically, in PVC, it releases a compound called hydrogen chlorine. Hydrogen chlorine is similar to mustard gas. Hydrogen chlorine, when you add water to it, becomes hydrochloric acid. And that, you know, is not good. Hydrochloric acid is extremely toxic to humans, and it also damages very expensive machinery, eats away at metal and steel. So now that we know what halogens are, we can move forward into understanding what low smoke, zero halogen actually means. Low smoke, zero halogen is typically a compound used in wire and cable for insulating and jacketing. Think of a structure anywhere in the world. This room, for instance, you need wire and cable to run your lights, your power, your sound system, fire alarm, communication systems. There's wire and cable, your computers, everywhere. So the role that wire and cable plays in a fire has been taking more into prominence. Low smoke, zero halogen emits very low levels of smoke and non-toxic levels of poisonous gases. This is a distributor, Houston Wire and Cable, promoting their version of low smoke, zero halogen cable called Lifeguard. These are pictures from a UL burn chamber. This one is PVC. When you light PVC on fire, you get an extremely large flame and this really thick, dense, toxic smoke. In contrast, low smoke, zero halogen, you still get the fire, but you can see it's much more clear. You can see the advantages of having this in a fire so that people can see where they're going, see exits and emergency signs. So low smoke, zero halogen isn't typically used for everything, but it should be used in public spaces and where people are present in confined areas. They should be used at train and subway stations, at airports, in the hospitals. They should be used on submarines and naval ships. In fact, the military was the first entity to adopt low smoke, zero halogen standards for all of their products. And now you're finding it more in residential, factory, and commercial businesses. Some of the pros and cons. Why don't people use this material all the time? Well, low smoke, zero halogen is very expensive. It's 3 to 4 times the cost of regular PVC insulating materials. It's also less available. There are less producers of the compound because of how difficult it is to make and how specially formulated it has to be. It's not as accepted in the United States. It's more accepted in Asia, Europe, and South America. And as far as specifications, engineering firms aren't as willing to specify the product because there is still some confusion regarding the flammability, the flame retardancy, and what standards it needs to be tested to. To summarize, I spoke a little bit about the 2 historical fires that pushed low smoke, zero halogen to the forefront in Europe. We defined what halogens are, their effects in a fire, what happens when you add water to that. We saw the devastating effects of hydrochloric acid and gas. And then we learned about what low smoke, zero halogen actually means, its pros and cons as an insulating and jacketing compound, and how it should be used in critical applications where safety to humans and equipment is paramount. With further research and investigation into low smoke, zero halogen, better technology to incorporate better flame retardancy, and improved processability, I believe the use of low smoke, zero halogen will become just as widespread in the United States. Thank you very much. Questions? Great, thank you.
All right, thanks, yes.